Hi, this is Todd with Lambda Math. In this video, we're looking at the right triangle, and mainly we're going to focus on the Pythagorean Theorem. We're going to talk about key terminology and a variety of examples of how you can find different measurements of the right triangle. So all that's coming up next on the Lambda Math. In this video, we're going to focus on the right triangle. We're talking about some key terminology and some other stuff that goes along with it. So one of our first key terms is we know that there's three sides to a triangle. In a right triangle, the two shortest sides are referred to as the legs. The third side, the longest side, is referred to as the hypotenuse. Now the hypotenuse is sort of directly across from the right angle. So if you look right across from the right angle, there's your hypotenuse. So those are our three sides. Legs are the short sides, hypotenuse the long side. Along with this, another key thing is something called the Pythagorean Theorem. And it goes something like this. It goes a squared plus b squared equals c squared. Now that may mean nothing to you, but basically the a, b, and c refer to the sides. The two short sides, the legs, are sides a and b. The long side, the hypotenuse, is side c. So those are where we're getting those letters from. So if we look at a triangle, for example, and we have sides a, b, and c, and if we said a, for example, equaled 3, it could be inches, feet, whatever, and then let's say b was 4, and let's say c was 5. If this actually worked out, we should be able to square each of these numbers, and it should equal c squared. So if a was 3, we're going to square it, we'll square the 4 for b, and we'll square the 5 for c. And when we do that, 3 squared we know equals 9, 4 squared is 16, and 5 squared is 25. If I add up the 9 and the 16, if I put those two together, we get 25. And as we know, 25 does indeed equal 25. So this is a right triangle. Okay, so first thing we're going to look at is how can you find the hypotenuse? So let's say we know two legs, but we don't know the length of the longest side, the hypotenuse. So this is the example we just kind of used. So we know that the two legs, the a squared and the b squared, are 3 and 4, but we don't know what the hypotenuse is, or side c. So we plug in the 3 and the 4, and we're going to square those numbers, but we're still keeping the c just c squared. As we said earlier, we know that 3 squared is 9, 4 squared is 16, equals to c squared, and we know 9 plus 16 is 25. Now, some people would think 25 is the answer to c. It's not. It's what c squared is. So we find the square root of both of these. The square root of 25 is 5, and the square root of c squared would just be c. So here's another example of this. So here's one where we know the two legs are 15 and 20, but we don't know what c is. So we're going to take the 15, and we're going to take the 20. We're going to go 15 squared plus 20 squared, and that's going to equal c squared. Because right now we don't know what c is going to be. We do know it has to be longer than 20 because it has to be longer than both the legs. Once we square these, 15 squared is 225, 20 squared is 400. So, and those two together are going to end up equaling c squared. So we add up the 225 and the 400, we get 625 equals c squared. 625 is not our length, it's just what the length is squared. So what we want to do is do the opposite or the inverse. We want to find the square root of it. So the square root, well, the square root of c squared is just c, and the square root of 625 is 25. So the length of side c is actually 25. Here's a third example. So on this one right here, now numbers are getting a little bigger. One of the legs is 186 meters. The other one is 248 meters. So we're talking some pretty big numbers here, and that's going to equal c squared. We square both of these numbers, and again, we're getting some huge numbers here. 34,596. If we square 248, we get 16,504. And those two together are going to equal c squared. So we add up the a squared and the b squared, and we're getting 96,100. Again, that's not the answer. That's what c squared is. So now we're going to find the square root of both of these. So the square root of the 96,100 is 310. The square root of c squared is just c. So that length, the hypotenuse, is 310. Now sometimes we need to find a missing leg. So we have the hypotenuse and we have one of the legs. So here's our first example. And we're going to use the 3, 4, and 5 that we used earlier. So this time we're missing the b. So we know a was 3, so 3 squared, plus b, we don't know what it is, but it's going to be b squared, will equal c squared, which we know is 5, so 5 squared. We know 3 squared is 9. We still don't know what b is, so we keep the b squared, and 5 squared is 25. So we have basically a little two-step equation here. So we're going to subtract 9 from both sides. That's going to leave us b squared equals 25. And again, 25 is not the actual length. So what we have to do is find the square root of both of these numbers. The square root of b squared is just going to be b. The square root of 16 will be 4. So the missing length here would be 4. Now some of you know that because we've already used this example a couple times. So that would be 4 meters. So here's another example. So here's example number 2. And again, we're trying to find one of the missing legs. So we know one of the legs is 12 and the hypotenuse is 20. So we've got 12 squared plus, we don't know what b is, so that would be b squared. And then we know our hypotenuse, or the long side, is 20, so this can be 20 squared. We'll go ahead and square both these numbers. So 12 squared is 144, we don't know b squared. And then 20 squared is 400. Again, we have basically a two-step equation. The first step is to get rid of the 144, and we have to do that on both sides of the equal sign. That leaves us b squared equals 256. We now want to find what b is, so we find the square root of it, and we find the square root of the 256, and we do that, we come up with an answer of 16. So that missing length right there for that leg is 16. Example number 3. So in this particular problem right here, again, we're missing a, we know the hypotenuse, we know b. So again, pretty big numbers here. So we've got a squared plus b squared, and that's 450, so it's 450 squared, and that's going to equal c squared, which is 750 squared. So now we have to just go and square those numbers. So we keep our a squared. 450 squared is 202,500, and then we're going to square the 750, which is 562,500. Just like the other ones, this is a two-step equation, so we're going to subtract the 202,500 from both sides. So we'll take that away from both sides. Now that's going to leave us a squared on the left side, and on the right side, after we subtract here, we're going to end up with 360,000. We're going to find the square root of both of these. So the square root of a squared is a, and now we have to find the square root of 360,000, and the square root of that would be 600. So the length of a, that leg, is 600. In this case, since we're using feet, it would be 600 feet. All right, example number 4 of finding a missing leg. So in this particular one, we have a decimal here. So we know a is 7.2. We know what the hypotenuse is 12. We got to find the b. So we got 7.2 squared plus b squared, and that's going to equal our hypotenuse of 12 squared. So we're going to take 7.2 and square it, and we get 51.84. And again, we got b squared, and then 12 squared is 144. So again, this is a two-step equation. We take away that 51.84, and we do that on both sides. On the left side, we're just going to be left with b squared. So that'll be what's on the left-hand side. On the right-hand side, we take 144 minus 51.84, and we get 92.16. Find the square root of both of these. Square root of b squared is just b. The square root of 92.16 is going to be 9.6. So the missing side here for b is 9.6. Okay, sometimes we have to determine, is this actually a right triangle? So we may not have like little right angles in it, or we're not sure if it actually really is a right angle. So this is an example we did earlier where this is a right angle because, or right triangle, because when we squared the two legs and we add them up, it was the same as when we added up or squared the hypotenuse. So 25 equal 25. So let's look at a couple other examples here. We're trying to decide if they're actually all the same. So example number 2 here. When we go to look at this one, we've got sides of 2 and 7 for the legs, and we've got 8 for the hypotenuse. So it would be 2 squared plus 7 squared equals 8 squared. Now, if they equal the same on both sides, it's a right triangle. So 2 squared is 4, 7 squared is 49, 8 squared is 64. On the left side, we're going to end up equaling 53, and on the right side, it's 64. So this is not a right triangle. The two sides have to be the same, and they're not. So this may look like a right triangle, but technically, based on the numbers, it's not. All right, example number 3. So we've got sides here of 6 and 8 for the legs, and our hypotenuse, I believe, is 10. So we're going to square the two legs, so 6 squared and 8 squared, and that's going to equal the hypotenuse of 10 squared. 6 squared is 36, 8 squared is 64, and 10 squared is 100. We add up the 36 and the 64. We get 100 on the left side, and we know the right side is also 100. This is a right triangle. And we know that because if we add up the legs when we square them, it's the same as the hypotenuse squared. All right, next up, example number 4. Trying to determine if these are actually right triangles. So we've got legs of 5 and 5, and we have a hypotenuse of 7. So we'll take 5 squared plus 5 squared, and that should equal 49 squared, or 7 squared. Okay, so 5 squared is 25, 5 squared is 25, and the 7 squared is 49. So I kind of jumped the gun there a little bit. If I add up the two numbers, the two legs, when we squared them, we get 50. On the right side, it was 49. They're not the same. They're very, very close. This would look like a right triangle. But because they're slightly different, it is not a right triangle. Well, thanks for watching the video. We hope it was helpful. We'd love it if you give a thumbs up, and we'd really love it if you subscribe to the channel. So until next time, we'll see you on The Land of Math.